Hello everyone. Here we are discussing second chapter of basic electrical engineering, and that is AC circuits. Now in AC circuit, previously we have discussed various AC circuit with only resistance, inductance and capacitance. Now in this video lecture we are going to discuss various series circuits, here in which we are going to start with our first series circuit, and that is RL series circuit. That means resistance and inductance are in series. So let's start the theory over here. Here what we are going to discuss, a AC circuit in which resistance and inductance is going to be in series connection. So here in this given diagram, one resistor is in series connection with one inductance where its values are defined by R and L respectively. Now this RL series connection, it is connected across a AC voltage source having value of Vt is equal to Vm sine omega t. Now when this AC voltage source will be provided to RL series circuit, it will provide alternating current, and that is going to be IT. Here, what we are going to do in this series, first of all, we will find out the value of this current. We will plot its waveform of voltage and current for this given circuit. Also, we will plot the phasor diagram for this circuit. And lastly, we will calculate instantaneous power and average power for this given circuit. But in our previous circuit, we had started with the derivation of the circuit current. And next, we had plotted waveforms, and next we had plotted its phasor diagram. But in this series connection, we are going to use some different method over here. First of all, we are going to plot a phasor diagram of this given circuit. And for that, we are going to consider few points based on our previous circuits over here. As an example, when we had discussed purely resistive circuit, and for that we had discussed that when we have a resistor and we measure the voltage across this resistor and current through that resistor, an angle between voltage and current of that resistor is zero. So here, if we consider a resistor and its voltage and current, so phase difference between this voltage and current is going to be zero, means both are going to be in same direction. But when we use inductor, there is going to be phase difference between voltage and current, and that is going to be 90 degree. If I say exactly, in inductor with reference to voltage, current is going to be in 90-degree lagging condition, and lagging condition, that means in clockwise direction. So here in this diagram we can observe that with respect to this voltage that is mentioned by VL, current of that inductor is at 90-degree lagging, means in the clockwise direction and at 90 degree. So by considering this, we are going to draw a phasor diagram for this given circuit. But here, when we will start the phasor diagram, as we discussed in our previous circuit, first of all, we need to plot a reference vector. Normally, in our previous circuit, we had considered reference as a supply voltage. But now we are going to change a thing over here, and that is now we are going to change a reference over here. We are going to consider current as a reference in all series circuit. And reason why? Because when we are discussing series circuit, there is a common parameter for all things, and that is current. We know that in series circuit, current is same for all components. So that's why we are going to consider current as a reference over here. So let's start the phasor diagram over here, and for that we had considered current as a reference, and that's why we had plotted current on positive x-axis. So consider that this direction, that is mentioning the direction of positive x-axis. So this is reference for us now temporary. Now I want to plot the VR voltage across register, and as I mentioned over here, if we consider the current of that particular register and voltage of that particular register, that are going to be in same direction. So if I consider current of this register, so that are going to be same, this is mentioned by this I. So with respect to this voltage of this resistor, we are going to be in same direction, which is direction of the current. So if I plot the VR, so that is going to be in the same direction of current. In same way, if you plot the VL, again for inductor, current is going to be same as this is series circuit, and with respect to this current, voltage of that inductor VL, which is mentioned over here, VL, here from this reference, if current is over here, so with respect to this current, voltage of inductor is in anti-clockwise and at 90 degrees. So similar way, if you put VL over here, so that is going to be at plus 90 degree with reference to current. You can see in both ways. With reference to current, voltage is in leading plus 90 degree angle, or in reverse manner. With respect to this VL, current is in lagging, means at minus 90 degree. And now next we want to find out the supply voltage. And as this is a series circuit, according to KVL, Kirchhoff's voltage law, what is supply voltage V? So here supply voltage V is nothing but a VR plus VL, addition of this two voltage drop. If I add VR and VL, that will provide the supply voltage VL, and that can be done by this vector addition. So this vector addition can be done by forming a parallelogram. So if you form a parallelogram between this VR and VL as shown in this figure, we have drawn the same vector in the direction of VR from the tip of VL, and same way you can draw the same vector as VL from the tip of VR, which shows this vertical line. So this resultant point will provide the addition of these two vectors, and that will define the supply voltage Vs. And if we need to find out the magnitude of this Vs, you can find out the length of that resultant, and you can measure the angle over here with respect to current, that let's say that is phi. But now from this given equation of supply voltage, if you observe this supply voltage equation, where Vt supply voltage is equal to Vm sine omega t, means phase angle of this supply voltage is 0, means after this omega t there is no phi angle, means phi is equal to 0 for this voltage. So if we consider that angle of this supply voltage is 0, if we consider that angle of supply voltage is equal to 0, then what will be the angle of current with respect to voltage? So let's find out the angle of current with respect to voltage. So here, with respect to the supply voltage Vs, that is nothing but a Vt. Current is in the clockwise direction, and first of all, clockwise direction is lagging direction, that shows a minus angle, and which is mentioned by this phi angle. So with respect to voltage, this is at phi degree. Now if based on this condition, if I define the value of current, so for that we had consider that value of this supply voltage, that is Vt is equal to Vm sine omega t. So based on this we can say that current is at a minus 5 degree. So value of current is going to be Im sine omega t minus 5 degree, which is mentioned over here. And what is the value of Im over here? That is going to be Vm by Z. What is Z over here? That is the total impedance of this R and L, and that can be find out by, if we can form we can write it down Z in vector form as a R plus JXL. And if we need to find out its magnitude, that is going to be Z is equal to under root R square plus XL square. That will define the magnitude of Z, which will be discussed later. But this is how we can define the current, and based on that we can do we can also plot the waveform of this given circuit. Here, as mentioned, the equation of supply voltage, that is Vm sin omega t. So angle of this voltage is phase angle, that is 0 by 0, because after omega t there is nothing, and that means phi is equal to 0 is over here. So waveform of this voltage is going to be start from 0 degree. Similar way, if you observe the equation of current, where if you observe the angle, that is omega t minus phi. So after omega t we have a minus phi, and that defines the phase angle of current. And we know that when we have a minus angle, that is after 0 point in the positive x-axis direction. So this waveform will start after 0 at 5 degree. So positive cycle of this current is starting after 0 at this 5 degree. So 0 is over here, and this positive cycle of this current is starting at this 5 degree after 0. So this is the waveform of current and voltage for RL series circuit. Now, if we calculate the power for this RL series circuit, so let's calculate the power. But first of all, let's calculate the instantaneous power. And for that, first of all, what is instantaneous power? The instantaneous value of power drawn by this circuit is given by the product of instantaneous value of the voltage and current. So basically, what is instantaneous power? That is the multiplication of instantaneous voltage and instantaneous current. So let's find out this value. Let's find out the instantaneous power. And for that, let's multiply the instantaneous voltage and instantaneous current. Previously, we had calculated the value of instantaneous voltage and instantaneous current, and that is over here. V is equal to Vm sin omega t, and I is equal to Im sin omega t minus phi. Here, Vm and Im, that are the constant term. So we are going to multiply the sine and sine term over here. So we had just considered this constant as a common over here, and we are going to multiply sine into sine. But if I multiply this term with 2, sine into sine, if I multiply this term with 2, that will provide 2 s's, 2 sine into sine. So that's why we had multiplied this equation with 2 and also divided this equation by 2. And that will provide 2 sine into sine, that is c minus c. Actually it is minus c plus c, but first of all we will subtract the angle, and next we will add the angle. That's why we are seeing that it is c minus c. So first of all, let's take out the constant as a common over here, and that is going to be Vm Im by 2 as a constant over here, and the rest term 2 sine into sine will be converted in form of this given equation, c minus c. First of all, let's find out first c, cos, and for that we are going to subtract this angle. So if I subtract omega t from, if I subtract this term from this term, this omega t minus omega t, so that will cancel out both omega t, and this minus into minus, that is going to be plus 5. So that's why we have cos 5 over here. And for second cos, means this term, we are going to add these two angles. So omega t plus this omega t, this 2 omega t minus 5. So that is the angle of this second cos. So this is the equation for instantaneous power for RL series circuit. Now based on this, we can also calculate the average power. And for that, to find out the average of this previous power, we can use integration method. Here we need to find out the average value. If we just integrate this value, we will find out area under this curve. But if we need to find out average of this value, then you have to divide that integration with base length. As we had considered integration in 0 to 2 pi, so base length is going to be 2 pi minus 0 means 2 pi. So that's why we need to divide this equation by 2 pi, and that's why this equation was divided over here 2 pi. Okay, so there is one small correction over here. We need to divide over here by 2 pi. Now, so let's integrate this given term over here. But before that, let me separate these two terms. First one cos phi and this cos 2 omega t minus phi. we will integrate both terms separately. For that we are applying integration on separate terms. That's why we had considered that integration of 0 to 2 pi for cos phi with respect to d omega t, and again we had integrated this second term separately. And if we integrate this first term, that is cos phi, and this is with respect to d omega t, so this is constant over here. And if we integrate these cos phi, so that is constant, so we are going to integrate of v1. So if we integrate v1, so that will provide the omega t itself. So omega t and limit are 0 to 2 pi. Similar way, integration of this cos 2 omega t minus pi, that is going to be first of all sine, and angle is 2 omega t. So here in omega t we have 2 in multiplication, so that 2 is going to be in division. So here term will be sine 2 omega t minus 5 divided by 2, and limits will be provided, that will be 0 to 2 pi. If we put these values over here, so if you put this value 2 pi minus 0, so that will provide 2 pi for this given term. So here we will have a 2 pi and cos phi will be as it is. And now for this second term, if we put this value over here, first of all, if we multiply this constant inside of this bracket, so this constant will be with this cos phi term which is over here, and if we multiply this constant again with the second term, so that will be over here. So as a constant, this is Vm Im by 8 pi, as 2 was over here and this was 4 pi, so we will have a 8 pi over here. And if you put the limits over here, then that will be 2 pi. If you put the omega t instead of omega t 2 pi, so that will provide the 4 pi. So first term is going to be sine 4 pi minus 5, and for second if you put the 0 value, so that is going to be sine 0 minus 5. So this is a second term over here. Now let's continue again. Here this term, that is sine 4 pi minus 0, but we know that if in angle we have a 2 pi or 4 pi, we can convert it in 0, because if you find out the value of sine 4 pi minus 5 or just sine minus 5, that is going to be same. So here instead of this term, we have replaced this term by sine minus 5. And again this minus can be taken as a common over here, so that is going to be minus sine 5. So here first of all we have a minus sine 5, and here we have sine 5 plus. So both are going to be, both will cancel out each other, that's why this term is going to be 0. So this second term will be 0, and that's why we will have a remaining term, and that is going to be Vm Im by 2 into cos phi. And again here in division we have a 2 term, and if we replace this 2 term by root 2 into root 2, so we will have a Vm by root 2 Im by root 2 into cos phi, and this Vm by root 2, that is nothing but a V RMS, and Im by root 2, that is nothing but a I RMS. So basically this capital V and capital I are representing the RMS value of this voltage and current. So final equation for this average power, that is Vrms, Irms, cos phi. So this capital I and capital V are nothing but the RMS value of this voltage and current. So this was RL series circuit. Thank you for watching this video. In our next video lecture, we will start our next series circuit, and that will be RC series circuit. So stay tuned.